Hello learners, in this video we are going to see error control coding. Error control coding is the coding procedure done to control the occurrence of error. This technique is helpful to detect the error and also correct the error. There are many different error correction codes depending upon the mathematical principle applied to them. But the code are have been classified into two main categories. One is linear block code and another one is convolution code. Before we are going to see linear block code and convolution code, we will see channel coding theorem. We know that the channel have the noise. The noise is present in the channel that creates the unwanted error between the input and output frequency. The error probability should be very low, which is less than 10 power minus 6 for giving a reliable communication. The channel coding in a communication system introduces the redundancy with control, so it improves the reliability of the system. The source coding theorem is reduce the redundancy to improve the efficiency of the system. So to improve the reliability of the system, the channel coding is used. To reduce the redundancy, we use the source coding theorem. Source coding theorem. The source produced by a discrete memoryless source is efficiently represented. This is the important problem in communication. In this, for example, in telegraphy, we use Morse code. The alphabet are noted by mark and space. Here, the letter E is considered, which is mostly used. So it is denoted by a dot. A letter Q is rarely used. It is denoted by dash dash dot dash. This is the source coding theorem. In this source coding theorem, discrete memoryless source produces the symbol Sk. It is the output of the discrete memoryless source, and source encoder produces the binary input to the channel. Source coder produces Pk. It is the output of the source encoder, which is represented by 0 and 1. The encoder sequence is conveniently decoded at the receiver. Source coding theorem. Let us assume the source have an alphabet with k different symbols. A kth symbol having the alphabet Sk occur with the probability Pk. Here the k value is ranges from 0, 1, k minus 1. The binary code is assigned to the symbol Sk and the length of the code is Ik. The average code by length L of the source encoder L is equal to summation k equal to 0 to k minus 1 Pk Ik. Pk is the probability of occurring the symbol Sk and Ik is the average number of bits per source symbol. Here, if L minimum is the minimum possible value of L dash, the code efficiency is defined as eta is equal to L minimum divided by L. When L dash is greater than L minimum, at the time eta value is equal to less than 1. The source encoder is considered efficient when eta equal to 1. So L value has to be determined. According to the definition, a discrete memoryless source of entropy h of del, the average code by length L for any n source encoding is bounded by L is greater than or equal to h of delta. In similar way, the Morse code of the Q, it is denoted by this symbol. It is always greater than the source code of Q, which means the symbol in the code is greater than or equal to alphabet in the source code. L is equal to h of del. The efficiency of the source encoder is defined in terms of entropy is written as eta equal to h of del divided by Ls. The source coding theorem is also called as noiseless coding theorem or error-free coding. This is the first theorem of Shannon's first theorem. Channel coding theorem. The channel coding theorem is consists of two parts of action. One is mapping and another one is inverse mapping. In mapping, Incoming data sequence is converted into a channel input sequence. In inverse mapping, the channel output sequence is converted into a output data sequence. The final target is that the overall effect of noise, channel noise, should be minimized. The mapping is done by the transmitter with the help of encoder, whereas inverse mapping is done by the decoder with the receiver. This is the channel coding theorem. TS is indicate the symbol period and channel capacity is indicated by C, and channel can be used for every TC time period. The maximum capacity of the channel is C by TC. The data sent is equal to H of del and divided by TS. When H of del divided by TS is less than or equal to C by TC, it means the transmission is good and can be reproduced with small probability of error. Thus, in this, C by Tc is the critical rate of channel capacity. If H of del divided by Ts is equal to C by Tc, the system is said to be signaling at a critical rate. Conversely, if H of S divided by Ts is greater than T by Tc, then the transmission is not possible. The maximum rate of transmission is equal to critical rate of the channel for reliable error-free message, which is taken over the discrete memoryless channel. It is called as channel coding theorem.